Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but a lot of the same principles apply over in the UK as well. Now, if you have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring that. And if you're watching this after the premiere, then just feel free to leave a comment underneath the video, and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on Diagnostics technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had a group of about 30 different franchisees I worked with, as well as the shops that they service, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so I worked in a dealership, and over time, I guess, I just became that default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that had come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic at hand today is actually, it's a two-parter, we'll say. It's a story in two parts. They are related to each other, but they are kind of two different things. It can apply to, the second part could apply to more things than the first part, put it that way. So it is a story in two parts. It is LIN bus and new module initialization. So the first part will be LIN bus. We'll talk about what LIN bus is and what it does. So much like any other network out there, pretty much definitely any network in the automotive industry, other networks as well, works on what we call a voltage differential. So the data needs to reside within a certain voltage range. And when a LIN, its voltage range is going to be roughly 12 volts. So in this case, we were looking at, it is a current sensor on a battery, runs a LIN bus, and it's about 13.35 volts at the top, and it's about 0.91 volts at the bottom. So I'm looking at a differential of about 12 volts, so 12.44 volts right there. So that is within the range of acceptable, so that is considered valid data, and that is how it will communicate. Now, LIN is a single wire bus specially developed to achieve cost-effective communication for intelligent sensors and actuators in motor vehicles. So the local interconnect network is what LIN stands for. Consists of a single wire with a transmission rate of up to 20 kilobits per second. It's not terribly fast in the whole grand scheme of things when it comes to data on a vehicle, but it's fast enough for what it needs to do. It doesn't need to drive the car down the road. It needs to open windows and change stations on the radio and things like that. That's mainly what it's for. It is a master and a slave type situation. So we have one master controller, and you can have multiple slaves off of it, up to 15. So it's up to 16 controllers together. And then they've actually been changing the verbiage over the last couple of years. So you may end up seeing in service information, if you haven't already, they call it a commander and responder instead of the master and slave. So just a change of the wording there. So we have our main controller here in this case, and then we have our other nodes, which are our receiver nodes down here down the line. So it could just be point to point, one thing to another thing, or it could be one thing to another module that then sends out signals to other things. It's just designed to kind of be switches, that sort of thing. So if we think about most common places that you'll find it, the roof, like the light sensors, light controls, sunroof. The sunroof button could be a LIN bus signal. Steering wheel, for sure. Many steering wheel buttons will have a LIN bus control aspect to it. So things like your cruise control, wipers, turning lights, climate control, radio, changing the presets on the radio, changing the volume on the radio. Seat. We're going to take a close look at a seat here in a minute. So things like seat position motors, occupant sensors, control panels on the seats, the switches on the seats. Engines, sensors, small motors, little things that aren't necessarily for drivability things like the grill shutter, right? We have the next thing down, active grill shutter is often contained within the ECM. Climate control, small motors, control panels. Think about your blend door actuators and things like that. Those are usually LIN. Not always. As I'm talking through all this too, it's not an always its LIN situation. Some manufacturers tend to use it more than others. I know I looked through the network diagram on my Kia, and there was only one LIN line in the entire vehicle, and it went from the front AC panel to the rear AC. And that was it, and that's just how it transfers data back and forth for what temperature it needs to be and all that. And then things like doors, right? So mirrors, central locking, mirror switches, window lifts, seat control switch, door locks, the things inside the window, like the the up and down of the motor and such, are control. The switches would be controlling it by LIN very often. So speaking of switches, this one I got off a Cadillac, and it says driver seat adjuster switch. Ground is supplied at all times to the seat adjuster switch. Battery positive voltage is supplied at all times to the seat adjuster switch through a 10 amp fuse located in the fuse block. When the seat adjuster switches are pressed, the appropriate signal message is sent to the seat memory control module via a LIN message. So it's connected to the module there. And then the module then commands the appropriate seat motor to move in response to the switch signal message. And it's the same for the other side. And then anything in the lumbar, it is also LIN serial data bus to the seat adjuster memory module again. So it's something like this. I'm going to have my switch here. I'm going to have my seat adjuster control module there. And then I have my 4 different motors in that case. So we have a front to back motor, up and down in the front, up and down in the back, and then the recline. It's got 4 motors. So the switch tells it to go forward, sends a control to the control module, or sends a LIN signal to the control module. Then the control module then tells this motor, okay, you need to move forward or you need to move backwards by changing the polarity of the voltage applied. So there's a common rail in there, and it just switches back and forth, either forwards or backwards. So the LIN involvement is from switch to module, and then the module to the motors is power and ground. So it's contained in the LIN there. We'll look at the wiring diagram here in a little bit to see kind of how it all ties together. And like I said, if you're going to look at the signal, this is your ones and zeros, right? So down is a 1, up is a 0. And when it's communicating, it is sending the ones and zeros back and forth in data packets. The modules need to have individualized IDs, which they would on that network, and then it would just address whatever module it needs. They all kind of listen at the same time, but if I'm module 2 and you say, hey, module 2, do this, that's what it would do. So it broadcasts to all of them, and it addresses by module address as to what needs to happen. So that is LIN, how it works in a nutshell. It's a fairly simple network. It just sends data back and forth. It's not like it's they say it makes it more simple. And I would say, as far as the wiring harness, I suppose it makes it more simple because I have a lot fewer powers and grounds and signals going around. It's just kind of the one network wire going back and forth. But it makes the modules and components less simple, because you're having to deal with microchips and processors and all sorts of things inside this. Used to be a window switch that would just make contact to power and ground a relay, right? And now it has to digitize that input and send it to the module over a bus. So it's more complex component tree, but it's less complex than the wiring harness, I think, would be the moral of the story there. Now this ties into new module initialization, right? Because sometimes you have to initialize the modules on a LIN bus, especially since many items on a vehicle nowadays, sensors, components, entire modules, need to have some sort of a process to tell the rest of the car that the module's been replaced and what what its ID number is, for lack of a better word. So if we think about like a home network, right? If you think about that, your phone has an IP address, your printer has an IP address, your scan tool has an IP address. All these components of the network have an address usually assigned to them by the router, right? So whatever the main gateway in the house would be assigning them digital ID numbers, basically. However, any device that has to connect to that network also has its own digital ID. It's called a MAC address. So in that case, it's very similar vein in the automotive world. I'm not sure if they have MAC address. I never actually bothered to research that deep into it because that's kind of getting into the weeds, but they all have their own digital identifiers in some way. I don't know if they necessarily call it a MAC address, but every module, component, whatever that has a circuit board on it, a logic board or whatever you want to call it, is going to have that on there. And then it needs to be paired to the vehicle. So for example, there's a few different ways that we can do this, depending on what the component is and how the manufacturer has it set up to be married to the module or what have you. So 5 different ways that we can do this. One is resets. Next is relearns. Then we have coding. Then we have programming. And then we have flashing or reflashing, depending on the software that's already on the module. We'll get to that here in a minute. So resets are the simplest thing. Resets are used to reset a parameter back to factory specifications after it's been adjusted. So for example, on a GM vehicle, I have an oxygen sensor heater that learns over time and increases the amount of current flow into the oxygen sensor to get the heater to heat up the way it normally should. So over time, it's going to increase that current flow. I replace it, I need to reset it back to factory. Otherwise, I might risk the chance of sending too much current to the heater and blowing it up. Transmission shift adaptives is another good example. So as you drive your vehicle, most modern vehicles since, I don't know, mid-2000s at least, they will adapt to how you drive. There could be different stages of adaptation, what have you. But if I do any transmission work, I will need to reset those adaptives back to stock, back to factory, and then it will relearn how you drive with the new components in place. So reset's very simple. In this case, we're going to go on this Tahoe, and we're going to go into service resets and relearns in this case, and then we have replace or relearn oxygen sensor there, and then we have the oxygen sensor heater learn right there. Easy enough. Click on it. It says on the next screen, select reset, and then you hit the little reset button on the top, and then it's done. It takes as long as tapping a button and checking a box, and it's done. Fair number of things on the vehicle that do this. It's going to vary from manufacturer to manufacturer, of course, but oftentimes components need to be reset in some cases. Next is relearns, so that kind of takes it another step further. So relearns are used to teach the ECM parameters of a replacement part. Big example here would be like a throttle body learn, especially on like Nissan vehicles. That's a pretty common repair. And that relearn can be a little tricky. There's many relearns out there that can be tricky for reasons we're going to discuss here in a second. But valve body learn's another one. So if we do any valve body work, replace the valve body, replace the solenoids in the valve body, may need to have a relearn there. And then TPMS is actually a relearn too. So each TPMS sensor is going to have its own ID number, own digital ID number. And either I've done a tire rotation, so now it needs to know the left fronts and the right rear, and I tell it what ID is on what corner of the car, or I replace the sensor, and I need to tell it, hey, here's the ID of the new sensor so you can address it and make use of the data that it's sending you. So that is actually a relearn process as well. So in this case, we'll go to service resets once more on this Nissan Murano, which is going to need a throttle body relearn. And then we would go to perform idle learn procedure in this case, because that's called the idle air volume learn, which is right there. Idle air volume learning is a function to learn the idle air volume that keeps the engine idle speed within a specific range. It must be performed under any of the following conditions. Each time the IAC valve, throttle body, or ECM is replaced. So if the throttle body replaced, it needs to be relearned. Idle speed or ignition timing out of specifications, which I think will be less common. Now we have to get into the mode. So perform accel pedal release position learning. So you're going to make sure the accelerator pedal is fully released. Ignition on for at least 2 seconds, off for at least 10 seconds, on for at least 2, off for at least 10. Then when that's done, hit continue. And then throttle valve close position learning. Make sure the accelerator pedal is fully released. Turn the ignition switch on and wait 2 seconds. Turn the ignition switch off and wait at least 10 seconds. And then confirm the operating sound of the throttle valve during that 10 seconds. So you'll should hear it go back and forth. Now, here's the important part. Not every manufacturer tells you this, but when the manufacturer does, you need to pay attention. Because this will fail if any of these parameters goes out of spec, and it tells you right there. Make sure all the following conditions are satisfied. Learning will be canceled if any of the following conditions are missed for even a moment. So battery voltage must be more than 12.9 volts at idle. Engine coolant temperature, 70 to 100 degrees Celsius. Move anywhere outside of that, it's going to fail. Gear selector and parker neutral. All electric loads off. AC headlamps for windscreen defoggers, cooling fans, etc. For vehicles equipped with daytime running lights, set the parking brake and the lights will go off. Steering wheel, straight ahead position centered. Vehicle speed, stopped at 0 miles an hour. Transmission warmed up, drive vehicle for 10 minutes. Yes, even if my coolant temperature is 180 degrees, if I haven't driven the vehicle and the transmission is not warmed up enough, then it won't work either. Key on engine running, idle not excessively high, all non-idle related codes cleared or repaired. So if any of these goes out of spec for just a moment, if for some reason it gets down to 12.8 volts at an idle, probably need an alternator, but that would cause an issue. If I get to 213 degrees Fahrenheit, I will probably have an issue. So just be aware. We get a lot of calls in the call center about, hey, this functional test isn't working. I'm having trouble with this functional test. And we go through them and we look through it. And most of the time, the issue is, the parameter probably wasn't met. I know I was trying to check transmission fluid on a Volkswagen DSG a couple months ago, and it won't let you do it until it's like 35 degrees Celsius transmission temperature. It was 34 degrees Celsius. So I had to wait and I had to rev up the engine a little bit and get that thing a little bit warmer. So it won't let you proceed, or it will fail, depending on what the test is, if you don't meet those parameters in a relearn. So in this case, if everything's okay, hit continue. If all conditions are met, key on engine running, select continue to start the test, and wait for test completed. So it would go through, let's say test in progress. When the test is done, we'll say test complete. Simple as that. Next level is coding. So coding is going to use to teach the ECM parameters by using a code number. It's right in the name, right? So for example, fuel injector coding, that is a very common coding procedure. I have to type in the numbers that are on the top of this fuel injector so that the engine computer knows how much to flow. Because every single injector coming off that assembly line, even if they were made at the same time, they're going to be slightly different. It's going to be slightly different tolerances. Maybe the spring tension is slightly different. Maybe the amount of windings in the coil theoretically shouldn't be different, but the resistance can change slightly. That's why they have ranges. But since there is a range, the computer needs to be able to know, based on its programming, what amount to flow that fuel injector because of its code. You punch the code number in, you're good to go. And then proxy alignment, which is actually an FCA Stellantis thing. It's been around for a few years. Body control module stores and compares vehicle configuration data with the instrument cluster as well as with other electronic control units in the vehicle. This process is referred to programming of configuration of systems integrated, or proxy with a CS, also known as proxy with an X. If a configuration mismatch is detected, the BCM sets a DTC. A configuration mismatch DTC will require the performance of restore BCM proxy configuration routine, or a proxy configuration alignment routine using a diagnostic scan tool. So if you replace anything, or for some reason it just forgets, these are code numbers that are stored, coding that is stored into the modules, and then they share it, which is vehicle configuration information basically, with the other modules. So I'm on a 2013 Fiat 500, and under body controls, it actually has its own callout under proxy alignment. And then we have perform proxy alignment procedure. Procedures used to display the proxy configuration status of the entire vehicle and copy the proxy configuration data into any required ECUs. Continue to display the current status. And then in this case, we see the instrument cluster and the radio are unknown, and the TPM and the CTM are configured. So it would take that pre-configured information and configure the other ones at the same time. So everything's in alignment, right? Complete the process, turn off the ignition, wait for the display countdown timer to finish. And then it'll say proxy alignment's done. Easy enough. We'll look through another example or two of that here in a minute. Next one's programming. So programming is used to change the ECM parameters using a preset list from the manufacturer. So for example, a lot of times this gets used in body control. So I want all the doors to unlock with a fob, or just one door to unlock with a fob. I want it to alarm chirp or not. Here's an example on a Subaru. I'm in the body control module, and I want to change the auto lock time from 0 seconds to something else. So I'm going to go to that parameter I want to change. I'm going to go to edit. And it looks like I can change it in 10-second increments up to 60 seconds. I want to do 20. And then I hit program. And then I verify that it says 20 there. And then I would hit program again. And then it writes the value into the computer. So it's a preset list of things that I can choose based on the manufacturer. And I have to plug that in there. Now sometimes it's not options like this. Sometimes it's, hey, what market is this module going to be used in? Because it's a global module. Could be used in Japan, USA, or UK, right? So you have to go in before you do anything. You have to put it into whatever market it's in, or you have to do some sort of unlock procedure where it's like take it out of factory mode or whatever. I've seen that plenty of times. So things like that where you're choosing from a list, or it's a yes or no, or that type of thing. It is a programming function. And then we get the flashing. Now, flashing generally isn't going to be used for components. It's going to be used more for entire modules. Flashing is used to write software to the ECM, and that's literally all it is. I'm either writing it or rewriting it in the case of a reflash. This comes back from way back. I would imagine before I was even born. Not that I'm that old, but still. Way back when they have this stuff called flash ROM, which they still use to an extent today. So you would need to flash the software onto this chip. And the name just kind of stuck and carried through. Nowadays, it's lines of code or whatever, and you're not actually burning it into a chip, but that's where it came from. So flash ROM. So examples: replacement of a blank module. You replace let's say I had a Jeep one time. I had to replace a ECM and it shipped blank because it fits multiple years and models. So you had to take the blank module and then you had to download from their website the proper module based on the year, make, model, and engine and all that stuff. And then you would have to flash it to the computer to make it work. Now, sometimes you also need to do coding or programming or whatever in order to make it work after that fact. Sometimes this is the first step, and you have multiple steps that need to be taken in order to replace the module. And then the other time you would use it is software calibration changes. So maybe a bulletin comes out and says, hey, we need to update the software that's on this pre-existing vehicle that's already been out there for however long. Example, mid-2000s, we had a big recall on Subarus because they were burning out a lot of cats. And the reason they were burning out a lot of cats was because they had the fuel mixture running too lean. They get great gas mileage, but they burn through cats in 60,000 miles or less. Sometimes. Depends on how they drove, of course. But so we would constantly get complaints after this recall that, hey, my gas mileage went in the toilet. Yes, I bet it did. Because one of the things that flash did was it richened up the mixture on the fuel tables. So that was a calibration change on the computer in that case. So it can be used to write or rewrite, but that's flashing. That's what it is. It doesn't do anything else. In order to perform a flashing type function on a vehicle, you will need a few things that are not a scan tool. You will need a laptop, a Windows PC, because no manufacturer out there requires anything that's not Windows. It's either Windows 10 or 11. There are certain levels of RAM that are needed. There are certain versions of web browsers that may be needed. There are certain websites that might need to be whitelisted. There's all sorts of different configurations that might be needed, but you do need a laptop, or I guess you could do it with a desktop as well. You need a pass-through device of some sort. J2534 is the protocol that it uses, and many manufacturers out there have them. The one we have is called a Pass-Through Pro 4. Pretty much one company makes it for pretty much everybody in the industry, so the box is the box. And then internet connection. Generally speaking, wired is better. There are some manufacturers that allow wireless, but I still believe many of them want wired connections because Wi-Fi can be spotty and drop out. And you also need a good battery maintainer. Just a little battery charger thing is not going to cut it. A jump pack is definitely not going to cut it. Some flashes can take 8 hours. Some flashes can take 3 days. Depends on the vehicle. So I need to be able to keep a nice, stable, steady voltage to this vehicle in order for it to work. BMW has upped the spec to, I believe, 90 amps is what it needs to be. So you need to have a good power supply with a good smooth, steady voltage, because if you have a voltage spike either up or down, you could break a module if you're in the middle of doing it. So that's at a bare minimum what you need. Then you also need a subscription to the manufacturer, or at least the manufacturer's software. I mean, I guess it's not technically a subscription if it's for a day, right? But I'm paying them to use the software for a day. Yeah, I guess it could be a subscription. So you can see the differences here. Some of it's out of date. I know, like Infiniti and Nissan went to a different model, but most of these are probably going to be pretty close. In the case of Hyundai and Kia, it's $75 a download. GM went to $45 a VIN. So you can flash any one VIN as much as you want over a 2-year period for $45. So I guess that's probably a good way to, if you're if you own a Corvette at home and you want dealer level, you could do that. I guess $45 for 2 years. It would work. So there's your different examples of how much it would cost to go through all different manufacturers. Subaru is kind of unique because they used to send out a DVD. I don't think they do DVDs anymore, but it's either a download package or it's a stick they must send out. But it's $75 a quarter, and you get basically all the flashes and all the whatever the current software is for Subaru. So they're kind of unique in the industry. And then you got Volvo with $6,500 a year. Holy cow! And that's more expensive than Mercedes by a lot. So they really don't want you doing the year option, I don't think, because it's considerably more than if I was going to pay. Actually, the month. Yeah, the month's about right. That's actually about even. So you get a considerable discount on like Mercedes. That's close. Anyways, there we go. Land Rover, $881 a month or $21.85. There we go. It's much cheaper to do it for the year. Anyways, you can see if you can get any dealer level diagnostics as well as what the reflash capabilities are on that manufacturer. Also, like I said, system requirements can vary. So here's an example from Ford. It wants Windows 10 Professional, preferably 64-bit. It can be 4 gigs of RAM, but they'd prefer 8. Solid state drive preferred, etc. It just gives you the different specs here. So every manufacturer is going to be a little bit different on what their specs need to be. And oh yeah, by the way, here's an example from Mazda. Mazda and Ford don't play nice on the same computer, so you have to have them installed on either separate computers or know how to partition a hard drive so you can partition them apart. And that's just one of many examples of what you might see out there. So you could deal with all this stuff if you want to. There's also people that I know have successful businesses that go around and do it as a sublet for people, or there is also this thing out there called a pass-through assistant. So this allows you to do I wouldn't say unattended, but you don't need to do the work. The tech on the other end of the line does the work. This is a Windows tablet with a power supply to maintain the battery and the electrical system, as well as the modem, Wi-Fi, and Pass-Through Pro inside. So it is just all in one box. It's like an SKB flight case, and basically you hook everything up. You set an appointment. They'll call you at the appointed time, and they'll walk through flashing it for you. Sometimes it might just be, hey, we need to turn the key on and off or whatever, but you don't have to worry about maintaining subscriptions or any of that stuff. They'll do it for you. It's just the box is the box, and it's the interface. Also with the box, we have added in the last couple of years repair guidance. So that is another thing that can be used to help if you get stuck in a bind or something like that, and you need to, you have a tough diagnostic related thing. These are OEM trained brand specific master technicians that will, basically they'll ask you, hey, what have you done so far? What are you trying to do? What have you done so far? And then they'll prescribe a plan of attack for you, right? So they'll say, hey, check this, check that. One example, I was talking to a BMW tech about it who works there. And he said, yeah, we had one call in one time. It was a pretty common problem that he had seen many times before. And he said, oh, yeah, don't worry about the flowchart or whatever. Just go down here underneath the passenger side carpet, find this connector, and you should find a loose wire or whatever it was. And sure enough, it was. So it's that type of stuff. It's having an A-Tech at your side for 2 weeks. And oh, by the way, it's only $50 of it. So I think that's a steal. honestly. And they're doing it for me, and I can pass all these costs along to the customer if I need to. So as far as coverage, the flashing support is not as robust as the repair guidance support because the repair guidance doesn't need any sort of licensing with the OEMs, and some OEMs don't approve of flashing over over the air when you're not present in front of the car. Sometimes the license doesn't allow that. So these are the manufacturers that they allow, and so if you have any of those and you need a flash, it will be able to be done, more than likely. And then if you need any technical help, it's over here. All right, so that is different ways to initialize a module. So let's go live and take a look at a couple different things. We're going to look at some wiring diagrams and things of that nature. And I need to pick a car first. So I'm going to go with this Cadillac first. And this is the seat we looked up, right? So go to seat motor. There. You go to operation. It's going to tell you pretty much the same thing I told you on the other screen. C memory control module controls all C motors via half bridges that are connected to a single power rail internal to the module. Module connects each of the C motor outputs together with the C motor's non-operation. C memory control module continually checks the motor control circuits for short circuit ground or voltage. And then it says down here, all C motors are reversible. For example, the seat switch is pressed to move the entire seat forward. A signal is sent from the seat adjuster switch to the C memory control module via LIN. In response to the signal, the module applies battery voltage through the seat horizontal motor, forward control circuit, and ground through the seat horizontal motor, rearward control circuit of the motor. So if we were to look at the wiring diagram on this module, this is lumbar, and this is lumbar again, four-way lumbar, memory switch circuit. So you have multiple switches in there to move it back and forth. Another way to do this, to find out where your LIN buses are on the car, because like I said, not every vehicle has it. A good place to look is if you can get the computer data lines. This is going to show us what we have for buses. So a lot of this is CAN bus, Ethernet even, private serial CAN bus. But if I come down here, I get to these green wires, and we have driver seat memory control module LIN bus 2. So GM's nice enough that most of the wires are green, or green with white, green with gray. But they will give you that trace, and that is a LIN bus. So you can see how it's from the switch. That's the switch itself, and it'll send it to this, and then that sends out to the other motors. And here's gateway module. That's going to have multiple different buses, but no LIN in that case either. If I come down here, we got some more LIN bus for the ultra high frequency, low energy remote control access sensors. So these are around the car. These are based on, when the fob gets close to the vehicle and unlocks, that sort of thing. So that runs off a LIN. Heads up display, steering wheel radio controls. That's all LIN bus. Come down here. Instrument panel cluster's got a LIN bus going in. I think we go way down to the body control module. I think it's at the end here. There we go. So body control module is going to have 16 LIN buses. As far as I can tell, there could be more, but there's only 16 that apply in this case. So LIN bus 16 goes over to LIN bus 16 is there. Remote function actuator module, top right of the C-pillar. So there you go. All sorts of different things on the bus. Heating steering wheel module even goes through a LIN bus as well. So a lot of different options for the LIN bus. And then, actually, if I look in the seat too, I'll look at the seat. Car seats. Right, so this is where they talked about, this is the actual module. We'll wire power and ground to it, and then it'll just flip what sees what to make it go forward or reverse. So that's part of the module. Now, as far as module setup, module initializations, that sort of thing, there's a few of those in here as well. On the scanner side of things. So I want to go into engine, for example. And there's learns and resets. And let's see. So seeing things like crankshaft position variation learn. I do any engine work, I need to redo that. There's that oxygen sensor heater resistance learn value. Throttle body idle airflow compensation reset. Turbocharger wastegate learn. I replaced the turbocharger. I need to do this. Fuel trim resets. Engine coolant control valve learn. Brake pedal position sensor learn. So it's not a brake switch, it's a brake pedal position sensor. Right? All sorts of different things in there. And other modules as well. Next one I want to go to is this Bronco, because that is going to give us kind of what was the whole impetus of this entire class here is body control module. And then going to functional tests and special functions, and we have a couple different things in here as far as setup. So we have LIN new module initialization, which is kind of what we're talking about this whole time here. Procedure will configure all BCM LIN nodes such as the rear view camera, intrusion sensor, rain sensor module, and battery monitoring system. After you select OK, some nodes might go into configuration mode. Continue. Turn the ignition switch on. And then it's going to send a command. It's going to be about 15 seconds and then about 5 seconds of waiting, and then it comes back. Give it a second to go through that. Or about 20 seconds to go through it, I guess. About 5 more seconds. There we go. Procedure successful. So that would just do the handshakes on all the modules and get them paired up to where they can communicate. Another example is a battery monitor system reset. So what that does is you have to do when the battery's replaced, body control modules replaced, or instructed by a workshop manual. I also know when this first came out, they talked about if you leave the key on for a while, like I'm cleaning the vehicle and listening to the radio, something like that, to save battery, once the battery gets to a certain voltage, it's going to start shutting off modules, and they won't reset for 8 hours. So this will force the reset on that. And then in this case, it says conditions not correct because it detected engine. And then we have programmable module installation. So this is another thing. If I needed to replace this body control module on this vehicle, I would want to bring the data out of it, the configuration data out of it, it copies it to the scan tool, and then you're able to take that data and put it in the new module when the new module comes in. So that's not a flashing thing. It's more of like a coding in that case because it's taking the configuration tables and stuff and taking them out and putting them in. So it's not actually flashing. But if you go to PMI, it's going to verify the VIN, read data from the old module. It's going to make sure the old one's still in the car. Hit yes. Turn the ignition switch on. I'm going to get an error because in this case, I'm not hooked up to anything, but it would pull it. And then I would go through my repair, replace the module, go back into PMI, verify the VIN, write the data, install the new module, and then it's going to paste it in there. It would pick the files that are stored locally on the scan tool. So there you go. And then the last thing I will talk about is this BMW. So on this BMW, there's a fair number of resets, relearns, configurations, initializations that need to be done. But if we go on the engine and special functions, battery replacement's a big one, right? So if I need to replace the battery, the charging system will adapt to the old battery. And if I replace it with a new battery, the conditions will be different to charge it. So we need to tell it that it has changed the battery. So we go to register battery exchange. And then replacement battery must be the same capacity and type as the original. And then program the next step, hit continue, and it's done. Easy enough. And other things like injection quantity compensation, that's a coding feature. We plug in the code. Starter exchange for the start-stop system. It resets the counter when you change the starter. Adjusting electromotive throttle controller, Valvetronic lift adaptations. Teach the acceleration sensor in there, register it. Register adaptation values. Of course, that one's not supported in the simulator. Things of that nature. So there's a lot of things that may need to be done when you replace a module on a vehicle. And LIN bus can participate in that as well. So in order to make sure the new components that are on the LIN, you may need to do a LIN bus relearn too. All right, so that is LIN and component initialization. And with that, that's our time here today. So make sure you tune in for new diagnostic content every week. We'll be premiering a new video every Wednesday at 7 p.m. UK time, so make sure to check it out here on our YouTube channel. Please make sure you also subscribe, thumbs up, and ring that little notification bell so you'll know anytime we post new content. With that, time for questions. Now, if you have any questions, once again, if you're watching this on the premiere, just leave it in the live chat and we'll do our best to answer those. Otherwise, leave a comment under the video and we'll get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've been giving you today. Hopefully we'll see you next week, and we'll see you on any of our other videos. Have a good week, have a good night, and take care.